Write on next topic. Oscillation of dipole, oscillation of dipole, oscillation of dipole in uniform electric field, oscillation of dipole in uniform electric field, and time period of uniform electric field and time period of electric dipole. Oscillation of dipole in uniform electric field and time period of electric field. So what is the formula for torque we have studied in terms of dipole? Tau is equals to Pe sin theta. Okay. So what is the formula for torque in terms of moment of inertia? Moment of inertia, system of particles and rotational motion. Force into momentum. Torque is equals to I alpha. Remember this formula? Torque is equals to moment of inertia into angular acceleration. Have you remembered at least this formula?
Yes, sir.
What is force in terms of rotation? Torque. What is mass in terms of rotation? Moment of inertia. What is mass in terms of angular acceleration? So tau is equals to I alpha. Now if I start rotating the object with respect to d theta, that is small angle, then what happens is I can rewrite this as tau is equals to Pe d theta. Okay, like initially this is my uniform field. I am keeping my dipole like this. So this is positive and this is negative. So which makes an angle theta here. Okay, this is my uniform field. It is going in this direction. So what is the meaning of dipole? Like opposite and equal charge will be there, right now. So if I take plus and this one will be minus. So with respect to field, it makes an angle theta. So that's why like torque will be equals to Pe sin theta. If I try to move either right side or left side, like it makes an angle d theta. Let me consider a small angle. Okay, just I have like what I can say is just I have moved that. Okay, so again it will return back to the original position. What is the meaning of oscillation? To and fro motion, no? So obviously when I try to rotate it with respect to d theta, it will get oscillation, no? So I have taken the formula here, tau is equals to Pe d theta. Now can I equate these two things? So I alpha will be equals to Pe d theta. So can I write alpha is equals to Pe d theta by I? Any doubt here? And the sign will be negative because it's a restoring force. If I try to move, again it will go to the original position. Okay, so this is formula for alpha. Take down. So what is the relation between acceleration and angular frequency and displacement? A is equals to minus omega square y, right now. So A is equals to minus omega square y. So here A is acceleration, omega is angular frequency and y is displacement. Okay, now I will write in terms of angular everything. Alpha will be equals to minus omega square and this is theta, angular displacement. Okay, so for the small displacement the formula will be alpha will be equals to minus omega square d theta. Okay, d theta. Can I compare these two things now? Alpha in left hand side and minus Pe by I into theta, so minus omega square into d theta. So can I write minus omega square will be equals to minus Pe by I, minus and minus will get cancelled off, omega will be equals to like dipole into electric field by moment of inertia, in under root it will come. Now what is the thing they are asking? Time period, no? So what is the time period formula? T is equals to 2 pi by omega. So 2 pi by root over dipole into electric field by moment of inertia. If I take this to the numerator, so 2 pi root over I by Pe. This is my time period formula in terms of dipole and electric field right now. First point, a capacitor is a device. A capacitor is a device that stores energy in electric field. energy in electric field. Next point, this energy is temporary, energy is temporary, and the potential difference drops, potential difference drops. Are not potential difference drops, that is decreases. As the energy is utilized. I will repeat the sentence. This energy is temporary and the potential difference drops as the energy is utilized. Third point, unlike a battery, where the chemical energy maintains, the potential difference. Okay, so only for some time the capacitance will, the capacitor will be used as a battery. It will store the energy. After it is utilized, energy will be zero. Okay, unless a battery, if you talk about battery, obviously it will give energy continuously, but capacitor, once it is utilized, it will drop the potential difference. Write down the next topic, capacitance. So which is denoted by the symbol C. Capacitance, the first point is denoted by the symbol C. Okay, so formula is C is equals to Q by V. C is equals to Q by V. What is Q there? Charge. V is potential and C is capacitance. Next point, the SI unit is farad. SI unit is farad. Okay, and the symbol will be looking like this, two parallel plates. Like in some textbook they have given the symbol like this also. These are the two symbols. Mostly we'll use this only. So from this, whatever question they are asking, we can write now like if capacitance increases, charge also increases. If capacitance decreases, charge also decreases. And if the potential increases, what happens to the capacitance? If the potential decreases, capacitance increases. Like I can say C is directly proportional to Q and C is inversely proportional to V and Q is directly proportional to V. If I take this V to the other side, Q is directly proportional to V. Write down. We can go for the next one. Write down next point. Generally the capacitance will be in microfarad or picofarad. Microfarad or picofarad. So micro, how much? Micro 10 power minus 6. What about pico? Minus 12. So generally the capacitance will be very small. Write on the next subheading, types of capacitor. Types of capacitor. Types of capacitor. Capacitor. First one is parallel plate capacitor. Parallel plate capacitor. Second one, cylindrical capacitor. Parallel plate capacitor. Second one, cylindrical capacitor. And third one is spherical capacitor. Spherical capacitor. Parallel plate, cylindrical and spherical. Under spherical a special case is there, isolated capacitor. Under spherical a special case is there, that is isolated capacitor. So whenever we are talking about capacitor, there should be two surfaces. So one will be positive and one will be negative. Okay. The first one, parallel plate capacitor. Write down the formula. C is equals to epsilon naught A by D. Epsilon naught A by D. So if I take this value, if I substitute in here, no, I can get the charge, no. Q is equals to CV. So where C is nothing but epsilon naught A V by D. This is my charge for the parallel plate capacitor. Initially we know the formula, C is equals to Q by V. From this I can say that Q is equals to CV. So parallel plate capacitor formula is C is equals to epsilon naught A by D, and from that I can say Q is equals to epsilon naught A V by D. So A is nothing but the area and D is nothing but the distance between them. Note point: when a dielectric is kept, then C will be equals to K times epsilon naught A by D. C is equals to K times epsilon naught A by D. Write on the next topic, cylindrical capacitor. Cylindrical capacitor. Write on the formula. C is equals to 2 pi epsilon naught L divided by log R2 by R1. This is for C. Capacitance of cylindrical. C is equals to 2 pi epsilon naught L. L is nothing but the length of the cylinder, and I told that two surface will be there. So for the capacitor, so obviously for cylindrical also two surfaces will be there. So one is R1 and one is R2. Okay, so two surfaces will be there, like outer cylinder and inside also one more cylinder will be there. Okay, two plates. Write down the next one, spherical capacitor. Spherical capacitor. So for spherical also, like two surfaces will be there, one is R1 and one is R2. Write the formula. C is equals to 4 pi epsilon naught, 4 pi epsilon naught. C is equals to 4 pi epsilon naught divided by 1 by R1 minus 1 by R2. 1 by R1 minus 1 by R2. Okay. Now the special case is isolated. Isolated. So isolated is nothing but I am taking this outer shell to the infinite. Okay, outer shell to the infinity. So if I take this to infinity, what happens? 1 by infinity will become 0. So what will be the formula from this? C is equals to 4 pi epsilon naught R1. 1 by R1 will go if to the numerator becomes R1. Isolated means the outer surface of the spherical taking to the infinity. So R2 infinity means 1 by infinity will become 0. So the remaining will be 1 by R1. If I take this R1 to the numerator, it will be 4 pi epsilon naught R1. Right on, next topic. Force between parallel plate capacitor. Force between parallel plate capacitor. Write down the formula. F is equals to Q square. F is equals to Q square by 2a epsilon naught. F is equals to Q square by 2a epsilon naught. Write down other formula. F is equals to charge into field. Charge into field. Electric field. Now there is a question. Write down. A parallel plate capacitor as an electric field, parallel plate capacitor as an electric field of 10 power 6 volt per meter. 10 power 6 volt per meter. Between the plates. Comma, if the charge on the capacitor, plate is 1 microcoulomb, then force on each capacitor will be. Force on each capacitor will be. Okay, try this one, get the answer. So 1 microcoulomb can be written as 1 into 10 power minus 6 coulomb, and electric field is given as 10 power 6. So F will be equals to 10 power minus 6 into 10 power 6, which is nothing but 1. Okay. So we got the force for the plates, but there are 2 plates. For each plate they are asking, so divide by 2, it is nothing but 0.5 Newton. That's the answer. If they are asking only force, answer is 1. They are asking for force on each plate. So each plate will be having 0.5 and 0.5. Write on next topic if you have completed. Completed. Done. Energy stored in capacitor. The next topic is energy stored in capacitor. Write on the formula. U is equals to of CV square. U is equals to of CV square. Write on the next formula. U is equals to Q square by 2C. U is equals to Q square by 2C. The other formula is U is equals to QV by 2. QV by 2. So if I see the first formula only, capacitor and the potential is there. If I talk about second formula, charge and capacitor is there. Third formula, charge and potential is there. If whatever they are mentioning, I can use the any one formula based on the given terms. Okay. So by you can take the first formula only. You know the formula for Q, that is nothing but C is equals to Q by V. Okay, I can substitute that formula here. So can I get that value? So 1 by 2 into Q by V into V square, V will get cancelled off. So 1 by 2 into QV. Am I getting the answer? Okay. Remember one formula and you know the formula for the capacitance and interchange the values whatever they are asking. Okay. Write down the question. If the energy stored in a capacitor, energy stored in a capacitor of 3 microfarad which has been doubled, then the charge must be increases, decreases or remains constant. Charge must be, options are increases, decreases or remains constant. All of the above, it's not possible. Either any one condition will be possible for the equation. Fourth option, there is no option for fourth one. Okay, this is your question. Next question. Sixteen picofarad, 16 picofarad capacitor is connected 16 picofarad capacitor is connected to 70 volt supply, 70 volt supply, full stop. The amount of electric energy stored in the capacitor is okay. Can you give answer for this question now? What is the formula for the energy? U is equals to of CV square, Q square by 2C, QV by 2. What are the things they have given? Cn, V they have given. Which formula can I use? First one. So take the formula and give the answer for this question first. The next topic is work done by battery. Battery. So formula is work done is equals to work done is equals to work done is equals to flow of charge into EMF. So what is EMF? So it is nothing but the potential difference. Okay. Write on the next formula. Energy density. Energy density. Write on energy density is equals to energy density is equals to 1 by 2 into epsilon naught E square. 1 by 2 epsilon naught E square. This is the energy density formula, and the SI unit is joules per meter cube. Joules per meter cube. Write down the question. A dielectric slab is kept between the capacitor full stop. Find the work done slash change in energy. Initially, change in energy initially, and after inserting of dielectric slab, Okay. So there is a capacitor and which is connected to a battery of 10 volt. So the capacitor is 10 microfarad. So the dielectric slab is K is equals to 2. This is the diagram. Take the diagram. First, like I will give a hint for this question. First you need to find what is the energy. U is equals to of CV square before inserting the dielectric slab. Then what I should do is I need to find the final energy, which is nothing but 1 by 2 K times CV square. I have inserted the dielectric slab. Then change in energy, which gives the work done. Yes, no, change in energy which gives the work done, no. So do this question, we will go for the next concept. Give some space for that question. I will give a hint, like I gave hint for this question. Initially I need to find what is the energy stored before inserting the slab. After inserting the slab, this is my energy. Then U final minus U initial will give the U net, that is nothing but the work done. Okay, write on the next topic. When the capacitor is connected to a battery, when a capacitor is connected to a battery, like it's a topic, completed this one. Write down the topic, when capacitor is connected to battery. So try to remember only this tabular column, it is easy to understand. So C, Q and V, and this is U, and one more is the energy density. Electric field. So distance is increased, area is increased, then dielectric is added. Okay, so the topics are like capacitance, charge, potential and energy, and the electric field, that is electric field. So what is the meaning of this is, there is a capacitance which is connected to battery. If I try to increase the distance, what happens to the capacitance, what happens to the charge, potential, energy and electric field, whether it is increasing or decreasing. Okay, the first one, distance is right. Completed? No. Okay, if distance is increased, capacitance will okay, can I start? So if a distance is increased, capacitance will decrease, Q also will decrease, potential will remains constant, hyphen, U will decrease, E also will decrease. If area is increased, capacitance will increase, Q also will increase, V will remains constant, U will increase and electric field remains constant. Done? We'll go for third one. So third one, dielectric slab, capacitance increases, like I'm multiplying the value, no? If I multiply the value, obviously the value will increase or not, the previous one, K times I am taking, no? So obviously the value will increases. So capacitance increases, charge also increases, potential will remains constant, U increases, electric field remains constant. Done. The next topic is the capacitor is charged. The capacitor is charged but not connected to the battery. Capacitor is charged but not connected to the battery. Capacitor is charged but not connected to the battery. Same tabular column. And V will be decreases, U decreases, and E also decreases. Okay, write down the next topic, capacitor in series and parallel. Capacitor in series and parallel. Capacitor in series and parallel. Capacitor in series and parallel combination. So it is quite opposite of resistance formula. Okay, for resistance, series will be R1 plus R2 up to Rn. For parallel, 1 by R1 plus 1 by R2 plus up to 1 by Rn. It is quite opposite of that. So C, like for series, no, the formula will be 1 by C equals to 1 by C1 plus 1 by C2. For parallel, it is C will be equals to C1 plus C2. For 2 capacitor I have taken, for n capacitor the formula will be keeps on going, C1, C2, C3 up to Cn, and for this 1 by C1 plus 1 by C2 plus up to 1 by Cn. Write down the point. For series, potential will be added. For series, potential will be added, like V is equals to V1 plus V2 plus up to Vn for series. For parallel, charges will be added. So Q is equals to Q1 plus Q2 plus up to Qn. Okay, now we will do the problem. కింద పడింది. What black magic, madam? Okay, this is the problem. I need to find the answer for the combination of the capacitor. Okay, how can I resolve this now? Don't do anything, just listen here. You can say whatever you can like whatever you understood. First one, what is the thing I can resolve which is parallel? Which is parallel? Like this, the diagram. Edi sir? Anni parallel. Anni series itla? If there is a connection in between, it will become a parallel, that's it. Yes, if it is a continuation, it will be series, no? If it is a continuation, it will be series. If any gap happens in between them, it will become parallel. Yes or no? Can I say these two are in series? From this point to this point, it is a continuation. So this is in series. First, let me find these two things. So 1 by 2 plus 1 by 2, I will get 1. Then can I take these two combination as a parallel? No. Okay, first I will resolve this. So after resolving this, I'll get as a one capacitor, right? No. Now this one and this one are looking like a parallel. Yes or no? Understood or not? After resolving this, I'll get only one capacitor, equal capacitor. Then these two are in series or not? Yes. After resolving this, I'll get only one capacitor. So these two are in parallel. Get the answer now first. Solve it, like use the formula 1 by C1, 1 by C2, C1 plus C2. First resolve this one. What is the answer you are getting? 1. Next resolve these two things parallel. 1 plus 1 is 2. You will get 3 things, no? So this is 2, this is 1 and this is 2. Again these two are in series. You will get 1. Series, no? 1 by 2 plus 1 by 2. 1. Again it will become 1 and 1. So it will become 2. 2 is the answer. First you try, I will resolve it, okay? Whatever I told you, try it, I will resolve this one. Get in, madam. Listen here. Listen. So this connection is in series. Okay, I'll resolve these first two things. 1 by CS will be equals to 1 by 2 plus 1 by 2, which is nothing but 2 by 2. So 1 by CS will be equals to 1. So CS will be equals to 1. Getting? Now can I take the diagram like this now? Now I have resolved as a 1. This is my diagram. So I can rearrange this one like this. So is this two are looking like a parallel? So parallel means like I have 1 this one, this also 1. So 1 plus 1 will become 2. So I'll erase this one, I'll take it as a single thing. So there is a connection in between there, right? No, but from this connection to this connection, a single wire is there. So in a single wire, 2 capacitors are there. It is in series. So can I resolve for these two things? Yes or no? Getting the point? Up to last point, any doubt? So in this, it is a single connection. There is no connection between these two capacitors. If there is no connection, this will be in series. If I talk about here, no, there is a connection between these two capacitors. There is a connection between these two capacitors. But there is no connection between these two capacitors. So if there is no connection between any two capacitor, that capacitor is called a series capacitor. If there is a connection, then it is a parallel. Okay. In this, any connection between them, so this one will be in series. Again, it will become parallel. I'll erase this one. I'll make it as a single thing. So it will become parallel. The next question I'll give. Try this one. C, 2C, 2C, 4C. Find out the answer for this. From A to B, I need the answer from A to B. As a single capacitor I need. So first two are in parallel, next two are in again these two will become series. Get the answer. Only calculation part is left out. Calculation you do it. Try to do it. Keep eraser also. After writing, erase it, okay? Done. What is the answer? Done. 2 is the answer. Done. Swatika madam, completed. Boys, doing. Completed madam. What is the answer? 1 by 2. Cross check it. Answer is 2. This side madam, doing. Done. 1 by 2. 1. Answer is 2 or 2 only, no? Check it. Last, madam, you are getting 1 by 2 or 2? 2. Next question. See, not every question is a different steps. Okay, like everything is a different model. Okay, I need answer for this question. Okay, now what is the thing is 1, 2, 3, 4 capacitors are there, and between these two capacitors there is a wire. Between these two capacitors there is a wire. Okay, wire. So wire means like same potential will be there. Okay, if I take a potential 1, so throughout the wire the same potential 1 only will be there. If I consider this as the second wire, so 2 means the same 2 only will be there, right? No. So if I talk about these two capacitor, in between these capacitor 1 and 2 is there, in between these two 1 and 2, 2 and 1, and in between these two, and for this only 2 is there. There is no potential difference. If there is no potential difference, neglect that. Where? If you are getting any kind of wire problem, okay, if any kind of wire problems are there, take a point of the first wire, see the wire where it ends. So throughout the wire the same potential. Okay, if I take this as 1 or A, this also up to this it will be A only. If I take this as B, so up to the last point it will be B only. Okay, so if I talk about this capacitor, the potential difference between this capacitor is AB. Okay, the second capacitor is BA, third capacitor is again AB, but fourth capacitor only one potential is there, there is no potential difference. What is the potential difference? If it is not there, it is a wire, no? then this is also wire only, no? If there is no potential difference, ఇది సేమ్ పొటెన్షియల్ కదా, మరి ఇది సేమ్ పొటెన్షియల్ ఉంటే ఇది వైర్ అవుతుంది కదా, ఎస్ ఆర్ నో? ఇఫ్ పొటెన్షియల్ డిఫరెన్స్ ఈస్ దేర్ దెన్ ఐ కెన్ కన్సిడర్ దట్ as a capacitor. If there is no potential difference, that is a single wire, so I can neglect this one, I'll write that as a wire only. Okay, now if you see AB, BA, AB, can I draw like this, three parallel AB, for first one also AB, second one AB, third one AB, that's the answer. Parallel plate capacitor, C plus C plus C, 3C is the answer for this question. Once again I'll explain. So there is 4 capacitor. Listen carefully. So from point A to point B, from point A to the second capacitor we have connected a wire. From the second, like in between first and second, we have taken a wire and we have connected between third and fourth. If wire is there, potential difference will not be there. Write the point. Wire, no potential difference, like potential difference will be 0. Okay, potential difference will be 0. If I consider this as A only, up to this point it is A only, no? Yes or no? Or if I take this as 1, up to this it is 1 only. So 1 going through this and it will be up to this 1. If I take the second wire starting this point 2, I am going the same wire up to the end, so it will become 2. If I see between this, it is 1 and 2, potential difference are there. If I see between this 2 and 1, potential difference are there. If I see between these two 1 and 2, potential difference is there. But if I talk about this one, only 2 is there. There is no potential difference here. So if there is no potential difference, what is this? So can I take it as a wire? That's it. Now 1 2 2 1 1 2. I can rearrange it. I can write this as, this is 1 1 1 2 2 2. So everything becomes a parallel and it's a parallel capacitor. Answer will be 3C. Write down. Next one we'll see infinity capacitor. Like the capacitor will goes on, okay, but I need to find what is the, no, we'll get the answer. In max, for example, if I talk about root 7 root 7 root 7 root 7 and it's going on, if I consider this as a x, okay, consider this as a x, can I consider the root 7 up to infinity as x. Getting the point? Root of 7, again root of 7, again root of 7, it is going on. So I will take this equation as equals to x. So x is nothing but root 7 times root 7 times, it is going on. Okay, it is, everything is in under root only. Okay, so it will be under root, under root, under root, and it is going on. Okay, if x is equals to root 7, 7, 7, 7, can I consider this as a x? Yes, no. So which is nothing but root 7x is equals to x, then, or I can take, for example, let me take like this, root 7 plus root 7 plus root 7 plus root 7 plus root 7, getting the point, which is equals to x.